Hey guys, today we are going to talk about exponential growth and decay. So at the end of this lesson, you'll be able to use logarithms to solve exponential growth and decay problems. We're actually going to do two separate videos. Today we'll do a video on exponential decay. Tomorrow's will be about exponential growth. Decay happens when a value depreciates over time. Depreciation is like the value of a car. When you buy a car, it instantly starts to lose value. That is depreciation. So anytime a value goes down, we're talking about depreciation or decay. So for exponential decay, there are two different formulas, and they have two different uses. So this formula, y equals a times 1 minus r to the t power, is for decay that happens by a fixed percent. This formula, y equals a times e to the negative kt power, is for when you're decreasing by a constant. Okay, so our first problem here is about caffeine in our coffee. A cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half of this caffeine to be eliminated? It's decreasing by 11%. That's a fixed percent. So we're going to use this formula, y equals a times 1 minus r to the t power. So let's talk about what y is. Y is the amount that we have left. Okay, so we want to know when we're going to have half of the caffeine eliminated. We started with 130, so the amount that we're left with will be half of that, which is 65. A is the amount with which we start. We started with 130 milligrams. R is the percent of decrease written as a decimal, so that's 0.11. T is the time. It says here time in years, but that time can be applied to hours, minutes, days. In this case, we are talking about how many hours it's going to take to eliminate that caffeine, and we don't know the time, so that's our variable. So we have 65 equals, so that's y equals a, which is 130, times 1 minus r is 0.11, to the t power. Okay, so now we're ready to solve. So we're going to divide both sides by 130. And we got this 130 this 65 by taking half of 130. So I know 65 over 130 is 1/2. That equals 1 minus 0.11 to the t power. 1 minus 0.11 is 0.89. So 1/2 equals 0.89 to the t power. Okay, now we know that we can use logarithms to solve an equation like this. So I'm going to put this into log form. So log, the base is 0.89, the argument is 1/2, the exponent is t. And we can use the change of base formula to solve this. So t equals log of the argument divided by log of the base. So I'm ready to put that in my calculator. Log 0.5 divided by log 0.89 is 5.95, and that's in hours. So in 5.95 hours, half the caffeine will be eliminated from the body. Example 2, the half-life of a radioactive substance is the time it takes for half the atoms of the substance to become disintegrated. All of life on Earth contains the radioactive element carbon-14, which decays continuously at a fixed rate. Fixed rate, that tells me we're using this right here where K is a constant. Okay, so we're using that second formula this time. The half-life of carbon-14 is 5,760 years. So that means every 5,760 years, half the mass of carbon-14 decays away. what is the value of K for carbon-14? So we want to know that decay constant for carbon-14. Okay, so it doesn't really tell us how much we started with, so we're just going to get to make up a value. Let's just say we start with 100 atoms. So the amount we're going to start with is 100. So that's A. Y is the amount we're left with. After a half-life, we are left with 50 atoms. Okay, half of it has decayed away. K is the decay constant, and we don't know K. That's what we're trying to figure out. And then T is the time. Okay, so the time is 5,760 years. We know that because when we said we started with 100, now we have 50. Well, it takes 5,760 years to decay half the mass. So after one span of 5,760 years, we took this mass and cut it in half. And now we want to know the decay constant. So the formula, y equals A times E, remember E is a number, not a variable, to the negative kt power. So y is 50 equals A, what we started with. Okay, then we have E to the negative kt, so times E to the negative k times T, and T is 5,760. Okay, so now we can begin to solve this equation. So we can divide by 100. So we get 1/2 equals E to the negative k times 5,760 power. Now if I want to get rid of this E, remember we can do a natural log on both sides, and that cancels out that E. So now we have natural log 1/2 equals negative, and I'm going to simplify this, 5,760 times k. So now I will divide by negative 5,760. Okay, so now it's time to bring the calculator back. So we've got natural log 1/2, so natural log 0.5, divided by negative 5,760, and we get 1.203 times e to the negative 4. So K is 1.203 times 10 to the negative 4 power. Okay, so that's an answer in scientific notation. That's a perfectly legitimate answer. What does that actually mean? That means we move this decimal 4 places to the left. So K is 0.001203. So that is our decay constant.